Welcome back to my channel, and today what we're looking at is how do we solve exponential equations. All right, so here we have 1 over 6 raised to the 3x plus 2 times 216 raised to the 3x is equal to 1 over 216. In order to solve this problem, one of the things that we want to do is we really want to have everything to be sorted in the same base, right? So we're going to represent everything to the base of 6. So I'm going to take 1 6, and 1 6 is actually the inverse. So it's going to be actually 6 raised to the first. That's what this really means. And times 2x plus 3x plus 2, and that will be multiplied by, this could be written as a 6 to the third, and then this is raised to the 3x, and which is equal to this right here. If we look at this right here, it's actually 1 over 6 to the third. But because this is the inverse, we can now represent this as 6 raised to the negative 3. All right, so having everything be written in the common base of 6, then what we can do now is to work on this side. So on that side, we do notice that we're multiplying, and so in working on that side, let us minimize everything first. This negative 1 right here will be used to multiply by this out here, right? Because when a power is raised to a power, you multiply. So this is actually 6 raised to the negative 3x minus 2, right? And this is being multiplied by 6 raised to the, so this will multiply by this because power raised to a power. This is 6 raised to the 9x, and this is equal to 6 raised to the negative 3. Now, because we have the same base and we're multiplying, then we're going to have this base of 6, but the powers will be added. For example, negative 3x minus 2, that power will be added, all right, to 9x, and that this is now equal to 6 raised to the negative 3. Now, what we're about to do though is to simplify this aspect of our math. So this is going to be 6 raised to the, so negative 3 with a positive 9, right, is going to actually give me a positive 6x minus 2, and that this is equal to 6 raised to the negative 3. Now, what this is though is we have now reached a very nice place where we're looking at the base of 6 on each side of the equation, which means that we can now equate the exponents, because if I have 6 raised to something and it is still equal to 6 raised to something, then the base could just easily cancel, and then we could solve 6x minus 2, which is equal to negative 3. What we're going to do here is to solve this equation ordinarily. So I'm going to add 2 to both sides. So 6x is basically equal to negative 1, and then dividing both sides by 6 so that we could solve here. So x is really equal to negative 1 6. So there it is. We solve a problem there. Let us take a look at another problem. So in this case, what we have is 243, and it is raised to k plus 2 times 9 raised to the 2k minus 1. This is equal to 9. Now we're going to try to represent everything in the same base, and we're going to have to use a base of 3 here, right, to facilitate everything. So what happened is this could be this part here. We're going to say this is 3 raised to the 5th power. So I'm just rewriting this. So 3 raised to the 5th power will give us 243, and then we have k plus 2 right here, and then we're multiplying this by 3 raised to the 2nd, and this is going to give us 9, and then here it is that we have 2k minus 1, and then out here we have 3 raised to the 2nd power. Now let us deal with our exponent, because when a power is raised to a power, you multiply the powers, and we're going to employ that right here. So with this said, we're looking at 3 raised to the, so we're going to have to distribute here. So that is 5k plus 10, and then this multiplied by, we're going to distribute here. We're going to distribute here. So this is 3 raised to the 4k minus 2, and this is equal to 3 raised to the second. Okay, now let us focus on the left side here. We are multiplying with the same base, so basically what we can do is we just add the exponent. So we're going to have the base of 3, and then we're going to have 5k plus 10 plus 4k minus 2, and this is equal to 3 raised to the second power. Let us analyze the left side, because these can be simplified, and we are going to do that. So in simplifying that, we're going to have 3, but 5k plus 4k will give us 9k. Positive 10 with a minus 2 will give us positive 8. And this is equal to 3 raised to the second. Again, we're looking at having the same base on both sides here. So if we have the same base, then we can logically conclude that this has to equal to this. So we could drop the bases basically and solve using the exponent. So 9k plus 8 is equal to 2. And then we're going to subtract 8 from both sides. So 9k is equal to negative 6. And then dividing both sides by 9, so that the k could stand alone. So typically we have k is equal to negative 6/9. And if we want to break this down by dividing through by 3, 3 into the 6 is 2, 3 into the 9 is 3. So finally, k can be represented as negative 2/3. And this would be our answer for k right there. Let us take a look at another problem. So with this problem, what we're looking at is we're looking at 16 raised to the r times 64 raised to the 3 minus 3r equal to 64. We're going to try to represent this using a base of 4 so that we could get this out. So 16 can be represented as 4 to the second power, and that will be raised to r, and then we're going to multiply this by 4 raised to the third. That's going to give us so 4 raised to the third is 64, and then on the outside we have 3 minus 3r, and then this is equal to 4 raised to the third. Now let us get our exponent in order. So we have 4. We're going to multiply these, because when a power is raised to a power, then we actually multiply the exponent. So this is going to give me 2r, and times, we're going to have to distribute here, right? We're going to have to distribute there. So this is going to be 4 raised to the 9 minus 9r, and this is actually equal to 4 raised to the third. At this time, we want to make sure that we only have one term on that left side, right? And it's good that we have the same base of 4, so we're going to keep that base. But what are we doing here? We are multiplying, and when we multiply, we add exponents. So in this case, we have 2r plus 9 minus 9r, and this is equal to 4 raised to the r. So here's the idea though. Finally, you could actually combine the 2r with the negative 9r. That's going to give us negative 7r with a plus 9. Right? Again, this 2r with a minus 9r will give us that 7r, okay? Negative 7r. And then finally, on the right side, we have 4 raised to the third. Again, because we have the same base on the two sides, and we only have one term on the right, one on the left, we could drop these bases and then equate the exponent. So in this case, we are thinking of negative 7r plus 9, right? and this is actually equal to 3. In solving this, we're going to subtract the 9 from both sides, so we're left with negative 7r, and this is equal to negative 6. Now we're almost there. The aim is to isolate this r, so we could divide both sides by negative 7, and then, so r, because negative 7 into negative 7, that's just 1. 1 times r is r, and we're left with 6 over 7. Now, whenever a negative is divided by a negative, then that's why we have a positive response in the end right there, okay? All right, so our final answer right here would have been this. Now, let us just take a look at the last problem, okay? Problem number 4 and the final. So we're looking at 16 raised to the 2p minus 3, and we're going to multiply that by 4 raised to the negative 2p, and it's equal to 2 raised to the 4th. Again, we're solving an exponential equation here, and what we want to do is we want to make sure that we have the same base before we could proceed. Yes, it's possible to work everything in a base of 2. So 16 could be referred to as 2 raised to the 4th power, and then we have 2p minus 3, and then we're going to multiply this by 2 raised to the 2nd power for 4, and then we have a minus 2p, and this is equal to 2 raised to the 4th. Again, let's get our exponential in order. We're going to distribute this 4 here, right? So basically we're going to have 2 raised to the 8p minus 4 3's 12 times, we're going to distribute here. As you could see, when a power is raised to a power, we're going to have 2 raised to the negative 4p, and this is equal to 2 raised to the 4th. Again, we want to condense this, right? Because it's the same base, so we could refer to everything in a base of 2, but, right, while referring to everything in a base of 2, we're going to have to take note that because we're multiplying the same base, we're going to have to add the exponent. So 8p minus 12 will be added to negative 4p. And as you could see, this is equal to 2 raised to the 4th power. Now we're going to simplify the exponent on the left side. So we have 2, but when you look at 8p with a minus 4p, that's going to give us a positive 4p and a minus 12, and this is equal to 2 raised to the 4th. Now, in a quick analysis, right, we only have 2 terms, one on the right, one on the left, and they're both they're both with a base of 2, which means that we could drop our bases and then work with the exponent. And by that I mean 4p right here minus 12, and this is equal to 4. So we're working with the exponents, and we're talking about 4p minus 12, and it's equal to 4. All right, we're going to add 12 to both sides because the aim is to isolate the 4p first. So this is 0. So what we have is 4p, which is now equal to 16 because this part gives us 16. Finally, I'm going to divide both sides by 4. Why? Because my intention is to isolate this p, right? So when we do that, this 4 cancels itself one time. So p is equal to 16 divided by 4 is 4. And there we go. Thank you for watching my channel, and see you next time where we will be looking at more videos.